Hello students, in today's lecture also we are going to solve the sums related to the composite function. But the difference is that in previous lecture we solved the sums where we apply chain rule only once, and here we are going to apply the chain rule 2 or more times. Now first differentiate the following with respect to x. Y is equal to square root of sine of x cube. Now before simplification we will observe the given question carefully. Now here at a time three type of functions are present. First root is given, then trigonometric function sine is given, and then algebraic function x cube is given. Now differentiating with respect to x, taking d by dx to both the sides, we will find out the term to which we are going to consider as x. Now first we will consider the sine x cube as x. So our function will be of the form root x, and we know the derivative of root x is 1 upon 2 root x. So here 1 upon 2 root x. While reading we will read that function as x, but while writing we will write the actual function, and the term to which we have considered as x, derivative of that term. So here derivative of sine x cube. In next step, keeping first this function as it is, here now again we will consider this x cube as x, means we will read this function as derivative of sine x, and we know derivative of sine x is cos x. So here derivative will be cos of x cube. While reading we will read this as x, but while writing we will write that as x cube. Then into the term to which we have considered as x, again derivative of that term, that is derivative of x cube. So in next step these two terms will be as it is, and derivative of x cube is 3x square. See, once again I am repeating. First we will find derivative of root considering sine x cube as x. So we will read this as root of x. In next step we will consider this x cube as x. So we will read this function as sine x. And in next step we will take derivative of that x cube. Means 3 times we will find the derivative of each and every term. So our final answer will be 3x square cos of x cube upon 2 into root of sine of x cube. Now second question, y is equal to cot square of x cube. Now here also we will observe the given question carefully. This cot square we can write as cot of x cube the whole bracket square. See here. So first we will apply the formula of x raised to n, considering cot of x cube as only x. So x raised to n. Then we will find derivative of cot of x cube. In that case we will consider this x cube as only x by reading the function as cot x, and in next step we will find the derivative of x cube. So first we will apply the formula of x raised to n, then we will apply the formula of cot x, and then again we will apply the formula of x raised to n. So see here, while finding the derivative, as we are considering this as x, so x raised to n. So answer is n into x raised to n minus 1. So 2 into cot of x cube, the bracket raised to 2 minus 1, that is 1, into derivative of the term to which we have considered as x, so cot of x cube. So in next step this term will be as it is, considering x cube as x, the term is cot x, and we know derivative of cot x is minus cosec square x. So answer is minus cosec square of x cube. Then again derivative of this x cube. So in next step these two terms will be as it is, and derivative of x cube is 3x square. So while writing the final answer, we will write this negative sign first, then this 3 into this 2. So we will get 6x square and the remaining terms as it is. Suppose we consider next question, question number 3. Y is equal to log of cos of x raised to 5. Here also first we will observe the given question carefully. First we will apply the formula of log x. In that case we will consider this cos of x raised to 5 as only x. So log x. Then we will consider the formula of cos x. In that case we will consider this x raised to 5 as only x. And finally the derivative of x raised to 5. So first applying the formula of log, then applying the formula of cos, and then applying the formula of x raised to n. So let's start to find the derivative. We know that the derivative of log x is 1 upon x. So here 1 upon x. See, while reading, we are reading this cos of x raised to 5 as only x. So derivative is 1 upon x. But while writing, we are writing the entire term. Into the derivative of that term we have considered as x. So cos of x raised to 5. In next step, this will be as it is. We know derivative of cos is minus sign. So here we have minus sign of x raised to 5 into derivative of x raised to 5. So in next step, these two terms will be as it is, and derivative of x raised to 5 is 5x raised to 4. So while writing the final answer, we will write this negative sign first, then this algebraic function 5x raised to 4, and we know sin upon cos is tan. So sin x raised to 5 upon cos x raised to 5 together we can write as tan x raised to 5. Now next, y is equal to x square plus 2x minus 3 the whole raised to 4 into x plus cos x the whole raised to 3. Now if we observe these two expressions carefully, then these are given in the form of u into v, where this first term is u and this next term is v. So here compulsory we need to apply u into v rule. We cannot take direct derivative of these functions. So here applying u into v rule, we will get u derivative of v plus v derivative of u. So here first u as it is, then we want the derivative of v, means derivative of this function. So here we are applying the formula of x raised to n. So 3 into x plus cos x raised to 3 minus 1, that is 2, into derivative of the term to which we have considered as x. So derivative of x plus cos x, plus this term will be as it is. Here applying the formula of x raised to n. So we will get 4 into x square plus 2x minus 5, the bracket raised to 4 minus 1, that is 3, into derivative of this term, that is x square plus 2x minus 3. So in next step, this term will be as it is, this term will be as it is, and we require derivative of this bracket. So derivative of x is 1 and derivative of cos x is minus sin x, plus again these two terms will be as it is, and derivative of x square is 2x and derivative of 2x is only 2, and derivative of 3 constant, that is 0. So while writing the last answer, first we will write the constant term 3, then these 3 brackets, similarly plus we will write this constant 4 first and these 3 brackets. So this will be the last answer. Now considering one more question, question number 5, that is derivative of sum is y is equal to log to the base 5 log x to the base 5. Now here, before we start to take the derivative, first we will simplify the given function. Now keeping this log to the base 3 as it is, we can write this bracket term as log x upon log 5, because we already learned change of base formula in 11th standard. what is the change of base formula? That is log b to the base a we can write as log b upon log a. So by similar case we can apply here. We can write log x upon log phi. Now we know that law of quotient is when the division is given we can write in the form of subtraction. That is log a by b we can write as log a minus log b. So similarly here we can write this term by using law of quotient as log to the base 3 of log x minus log to the base 3 of log phi. Now again here we can apply change of base formula. So we will get this as log of log x upon log 3, keeping this term as it is. Now you can ask the question that if here we are applying change of base formula, then why not here? Because here no x term is present. Log 3, log phi, all terms are constant. No x term is present. So finally we will get derivative of this term as 0. So no need to convert by using change of base. So differentiating with respect to x. Now here we know that denominator log 3 is constant. So that we will write outside the derivative, and derivative of log x and minus derivative of this term. So here 1 upon log 3 as it is. Derivative of log x. Now we will consider this log x which is given in the bracket as x. So derivative of log x is 1 upon x, that is 1 upon log x, into the term to which we have considered as x, that is derivative of log x. And we know derivative of constant is 0. So here we will write 0 because this is constant. So 1 upon log 3 into 1 upon log x into derivative of log x, that is 1 upon x. This whole answer we can write as 1 upon x into log x into log 3. Okay. Thank you students.